When making textures in Blender, we use vectors in order to determine where our texture will show up on the object. Essentially in maths, vectors are like a box of numbers, the box being represented with big brackets in maths. Looking back at the dimension options on the noise texture that we covered in the last tutorial, if we were to set the option to 2D, it would only access the x and y coordinates, meaning z is as good as 0 no matter what it's changed to. 3D and 4D will have the x, y, z coordinates. 4D will also have the W to act as a fourth dimension. However, it's important to keep in mind that this is not the fourth vector dimension. As for 1D, the same applies here. Since it is controlled by a W component, it isn't controlled by the vector. Going back to 3D noise texture, these three numbers determine the texture's position in X, Y, and Z, and will remain the same even when you move the object, as these coordinates are relative to the object, not to the world space. Although, if you move the object in edit mode, you will see the texture move. That's because in edit mode we are essentially moving the object within its own local space. To summarize, in Blender, a vector is a combination of X, Y, and Z texture coordinates. We can get these from an input node, such as the texture coordinate, or do it manually if you know how to do that. There are also 4D vector in Blender, which we will cover later. In Blender, negative and positive vectors are represented with an RGB color system. However, since negative vectors are like a negative color, which we can't see, the negative vector values are displayed as black. As for positive vectors, X, Y, and Z have a corresponding color. The X coordinate is represented with red, the Y coordinate is represented with green, and the Z coordinate is represented with blue. So, handily, it's the same order as RGB, so that can be a good way to remember it. Since it goes from X to Z, it's red to blue. So, that's the vector socket. But what about the color socket? Does this have anything to do with vectors? Well, yes it does. Unlike the vector sockets in Blender, all color sockets are actually 4D vectors. This means that instead of having 3 numbers in the box, like for a vector socket, the color contains 4 values. These are represented with red, green, blue, and alpha. So what happens then when we plug a vector into a color socket? Well, actually, since color socket is a vector, and vector socket, the purple one, has each coordinate represented with a color, it means it can translate into the RGB format that the color socket has. So even though the vector socket is represented with XYZ, XYZ respectively are represented with RGB. And so when we plug that socket into a color socket, it translates perfectly since the coordinates will just become their respective color. This means that they can essentially be accurately translated into the color socket. But then what about this alpha channel? Well, since a 4D vector can't turn into a 3D vector, whenever you plug the color socket into a vector socket, the alpha channel will just simply be removed, so you don't need to worry about it influencing any of the other 3 values. To summarize, this means that the vector socket can go into the color socket since XYZ is represented with color, and the color socket will also add 4th dimension alpha, but although it will be removed when converted back to the vector socket, which only has a 3D vector. To view what the vector color looks like, I'm going to use this as a chance to enable one of Blender's free add-ons, which we mentioned before, called the Node Wrangler. I'll left click on edit on the top of my screen, then left click preferences, and I'm just going to search for Node Wrangler under the add-ons tab. Then I'll check the box, and then left click the 3 bars, and then press save preferences. Then I'll just press X to close out that menu. In order to give you a bit of a demonstration here, I'm going to change my timeline to the shader editor. Then I'm going to press this plus new here to add a texture, and I'm going to move into my material preview so I can actually see the changes I'm making. I'll left click and drag on the top of the shader editor menu to bring it up, and I'm going to left click and drag these 2 nodes here. Now I'm going to press shift and A, and I'm going to use combine XYZ, and I'm going to press Control, Shift, and left click on this combine XYZ. So as you can see, since the X, Y, and Z values are all at 0, that means the output will be black. But if I was to turn this X value to 1, what color do you think it will turn into? Have a guess. If you guess red, you are correct, and that's because X is represented with red. If we increase it further, it will just increase the intensity of the red to a certain degree, and then the changes become pretty much unnoticeable. I'm just going to return the X coordinate down to 0 by left clicking so it highlights and then typing in 0 and then enter. Then, as you might imagine, if I set the Y to 1, it's going to become green. I'll left click and set it back to 0, and I can also left click the Z and set the value to 1, then it will become blue. You can notice if I change the values of more than one vector, you get multiple colors. And if I set all the values to 1, you'll get white. That's because all the colors added together will make white. That's great, but how else can Node Wrangler help us? Well, I'll show you just now. So I'm going to press Shift and then A, and I'm going to left click on noise texture. Then if I left click and drag my color into base color, and left click and drag my BSDF into surface, you can now see what our noise texture looks like. If you're confused as to why there's color here, that's because I've got the color socket into base color, whereas in the last episode we were mainly focusing on putting factor to base color. So I'm going to return that to color. Now if I want to quickly add a vector coordinate to this, I'm just going to left click by noise texture and press Ctrl T, and you can see that's generated that mapping node and texture coordinate. So what exactly do these do? Well, there's loads of different options here on the texture coordinate. Essentially what this texture coordinate does, if I unplug it, you can see under vector, these are our vector coordinates. So these will determine how the image is shown on our object. So generated spreads the texture across the object automatically, using the vertices of the object as a reference while minimizing distortion of the image. This is something I found out on the Blender wiki, so you can go have a look and read that for yourself if you're interested. The link will be in the description. Then we've got UV. This will essentially place the image on the UV and it will be displayed on the object that way. To remind you what the UV looks like, I'm going to come to the top left hand corner, drag this out, and I'm going to left click this, and I'll left click UV editor. Then when I press tab and go into edit mode in my 3D viewport, select everything, you can see here we've got this cross shape, which is essentially the 2D version of this object. It's almost like imagining a papercraft version of this object. So coming back to our texture coordinate, when I take this UV coordinate and plug it into the vector, the texture coordinate is essentially telling the vector to use this UV here to figure out where to put each square. And you can see this in action if I press free in my UV editor to go into face select mode, and I left click one of these faces and drag it about, you can see it's altering the image. The other one I'm going to talk about today in the texture coordinate is called the object. So if I drag and drop that into vector, you can now see when I alter my UV, there's no difference. And that's because it's not accessing the UV anymore. Rather, it's using this object texture. So what does the object texture coordinate do exactly? Well, it essentially takes the information of the object and calculates the best way to equally spread the texture across the object. However, as we briefly mentioned in the last tutorial, this doesn't really work with the brick texture. For the brick texture, you're better using a UV coordinate. But for things such as noise textures and Musgrave textures and Voronoi textures, I usually use the object coordinates. But you might be wondering then, when I bake, doesn't it only work if I use the UV texture coordinate? No, that's not true. All that's important for baking is that you have a UV in the first place. What texture coordinate you use is not related to that. It will only affect the appearance. Now we're going to move on to the mapping, which is a very useful node when creating procedural textures and for just texturing in general. So you can see we've got values for location, all acting on XYZ. We've also got rotation and scale. So if I move, for example, the X location, you can see that this face here is moving along the X axis. I can left click this and return it to 0. As you might imagine, when I left click and drag the Y, it's now going to move it along this green line here, which is the Y axis. You can see it changing. So return this back to 0, and as you might have guessed, the Z will do the same thing. So now it's moving up and down. When I left click the Z and turn it back to 0, rotation, as you might imagine, will rotate it on the respective axis. So if I was to change the rotation of this X, it will rotate the texture across this red line here, like so. Keep in mind, however, as I mentioned earlier, vectors work in the local space. So if I was to press R on my object, Z and 90 to rotate at 90 degrees, notice if I continue altering the rotation of my X axis, it's still doing it on the same face. And that's because this object's local X axis is where the green line is now. If we wanted to change that, we would just press Ctrl and A, and this time we would apply the rotation. And essentially what that does is returns the rotation to its default value. And now when I alter the X rotation, you can see it's now working in accordance to the global coordinates, which are represented with this green, red and blue line here. So I'll left click this and return it to 0, and you can see when when I rotate it on the Y, it'll rotate it around that green line. And you can see it's also rotating here, just like round these 4 faces, almost like a spinning tube. So I'll left click this and return it to 0. And Z, as you might imagine, it will now rotate from the top like that. So you can see it spinning that way. I'll left click that and return it to 0. Next up we have scale. So scale is really useful. I usually use this in like basic wood textures and stuff. So for example, if I was to scale the Y, it's going to scale across this green line here. And you can see it's now getting smaller, and that will work really nicely for like a wood texture. You can also scale it on the X, like so. And now you can see we've almost got kind of a log look. And for the top 2, we could probably replace that with a different material. If I reset the scale to 1 by left clicking the top one and quickly dragging down and set the value to 1. If I turn this Y value, for example, down, you can see texture gets bigger this time. Although once we enter the negative numbers, it will start generating more noise again. And the other cool thing to remember about all these built-in textures in Blender is since they're mathematically calculated, we could go as crazy as we want with any of these values. Like let's say I could change my Y to like 100, and we're not losing any resolution here because it's all being calculated mathematically. So that's what separates the built-in Blender textures to like an image texture, because an image texture has like a resolution limit, so eventually it would start looking really pixelated. But since this texture is calculated mathematically, no matter how big or small we go, the resolution will still look brilliant. So that's another handy feature about the built-in textures in Blender and why they're so powerful for procedural materials. I'm now going to reset my Y value to 1, so it's now back to the default. So yeah, essentially this mapping node is an excellent way to quickly modify how our texture looks. This can also be used with your image textures as well to move it along or to rotate or scale it. Although like I mentioned, do keep in mind that the resolution isn't infinite on an image texture. So some of you might be wondering, you may have seen in YouTube videos before that people will use a node under the vector called bump. So this is represented with a purple socket and it's adding normal information here. Well, we're going to be covering what normals are and the functionality of displacement and bump in a later tutorial. For now, I just want you to try and digest what we've learned today about vectors. The final thing I'm going to cover in this tutorial is the grey socket. What exactly is this grey value? If I was to press Shift and A, come under input and then left click value, this will give us a grey value. So if I plug this value into our vector here and I set this value to 1, it will be telling this vector here to set X, Y and Z all to 1, since essentially what the value does is it spreads the same number across all 3 values. So this will also work the other way around. If I was to plug a vector into a grey socket, it would essentially calculate the average, and that's what the grey socket value would become. Great, so now I've covered that, we're going to quickly have a quiz. So well done for completing this tutorial, since it is quite an intimidating one. Number 1. What node gives us a coordinate which allows us to determine how the texture is spread out on the object? Number 2. What vector node allows us to further tweak the texture's appearance on the object in an easy way? Number 3. How many dimensions does the vector socket and color socket have respectively? I'll be going over the answers in 15 seconds. Feel free to comment your answers down below and I'll mark them. Number 1. What node allows us to get a coordinate to determine how our texture is displayed on the object? The node we covered today was the texture coordinate. This will give us vector coordinate information which we can plug into our vector to determine how the texture will be spread out onto the object. Number 2. What vector node allows us to further tweak the texture's appearance on the object in an easy way? This would be the mapping, because the mapping node allows us to further tweak the location, rotation and scale values and then give us a vector output for that. That way we can make easy tweaks to how the texture will appear on the object. Number 3. How many dimensions does the vector and color have respectively? The vector socket is a 3-dimensional vector represented with X, Y and Z, which are also represented with a color, X being red, Y being green and Z being blue. The color socket is a 4-dimensional vector determined by red, green, blue and alpha. Great job everyone for making it this far in the tutorial. Next episode we'll be covering what shaders are, but with that I want to thank you all for watching and I'll see you in the next video. Take care.